EtherType is a two-octet field in an Ethernet frame. It is used to indicate which protocol is encapsulated in the payload of an Ethernet frame. This field was first defined by the Ethernet 2 framing networking standard, and later adapted for the IEEE 802.3 Ethernet networking standard. Overview: EtherType numbering generally starts from 0x0800. In modern implementations of Ethernet, the field within the Ethernet frame used to describe the EtherType also can be used to represent the size of the payload of the Ethernet frame. Historically, depending on the type of Ethernet framing that was in use on an Ethernet segment, both interpretations were simultaneously valid, leading to ambiguity. Ethernet v2 framing considered these octets to represent EtherType, while the original IEEE 802.3 framing considered these octets to represent the size of the payload in bytes. In order to allow packets using Ethernet v2 framing and packets using the IEEE 802.3 framing to be used on the same Ethernet segment, a unifying standard was introduced that required that EtherType values be greater than or equal to 1536. That value was chosen because the maximum length of the data field of an Ethernet 802.3 frame was 1500 bytes. Thus, values of 1500 and below for this field indicate that the field is used as the size of the payload of the Ethernet frame, while values of 1536 and above indicate that the field is used to represent EtherType. The interpretation of values 1501 euro 1535, inclusive, is undefined. The size of the payload of non-standard jumbo frames, typically 9,000 bytes long, falls within the range used by EtherType, creating a conflict. The proposition to resolve this conflict was to substitute the special EtherType 0x8870 when a length would otherwise be used. With 802.1 QVLAN tagging and QINQ, the sparse 16-bit EtherType is being completely used. The 16-bit EtherType not only tags the payload class, it also serves to help end any VLAN tagging or QINQ stacking. Via look-ahead peeking and streams, the 16-bit EtherType can help to confirm or package a QINQ 32 plus 16 equals 80-bit header between the 48-bit MAC addresses and the payload. Of those 80 bits, only 32 bits are used for dynamic information. For a full 66-bit addressing system, 18 bits are needed beyond the MAC. Thus, additional EtherType values are required and used for triple tagging QINQ. Inefficient and conservative use of a 16-bit tag protocol identifier on each 32-bit VLAN tag, followed by the trailing lone 16 bits, creates a 48-bit signature that cannot easily be mistaken as part of the payload. Vendor implementations may avoid wasting bandwidth sending those 48 bits in proprietary link compression schemes. The EtherType usually does not contain any CRC or FCS information. With the advent of the IEEE 802 suite of standards, a subnetwork access protocol header combined with an IEEE 802.2 LLC header is used to transmit the EtherType of a payload for IEEE 802 networks other than Ethernet, as well as for non-IEEE networks that use the IEEE 802.2 LLC header, such as FDDI. However, for Ethernet, the Ethernet 2 header is still used. Examples: note that even very well-known de facto uses of EtherTypes are not always recorded in the IEEE list of EtherType values. For example, EtherType 0x0806 appears in the IEEE list only as symbolics, incorporated, protocol unavailable. See also, physical coding sublayer, references. External links, IEEE Registration Authority tutorials, IEEE EtherType Registration Authority, IEEE Public EtherType List.